So in the past 2 days, we were doing regressions, but we were doing linear regression 2 days ago, and then yesterday we did quadratic regression, right? So the polynomial regression. Today we're going to talk about exponential regressions, and these are the 3 that we will be discussing and we will be focusing on in this course. Okay? So remember, if you are taking this correspondence or if you do this in the regular schools, they actually make you do it by hand. But then how are you going to use that when you go to college? I don't know. That's why remember that college, you're going to have to use Excel. You're going to have to know how to use it. So get used to this. All right? So exponential models. What do we know about exponential models? How do they look like? How does a graph look like? How does the equation look like? It's a curve. Can you explain that curve a little bit more? That's right. So it's slow and then it goes faster, right? So it's horizontal at in one area and then exponentially growing fast in the other side, or going down fast and then slow. That's right. And so we have 2 kinds of exponential. We have the growth, right, which we explained first, right? So it's slow and then it grows fast, or the decay, which is going down, basically fast and then slow down. How does the equation look like?
X squared plus bx plus c.
That's quadratic.
It has a power of more than 1, 2.
What's quadratic?
X.
The 1, the 2.
X.
The exponential. So what would the exponent be?
X.
It's a variable, right? So your exponent is a variable, is x. Remember that from the previous unit, right? Okay, so in the table of value, so let's just take this one. So exponent models represents quantities that change at a constant percent or rate, right? So we're changing at a constant, so it's, if we're doubling every single time, right? That's a constant change. Tripling, or if we're halving, or if we are changing at 5%, right? So we're changing in the same percentage. In a table of value, we call them the growth or decay factor. Are equal. So the growth and decay factor are equal. Do you remember how do we find that in the table of value? What do we have to do? So it's not the first difference, it's not the second difference, it's the, starts with an R. Ratio. We have to do ratio, which is dividing y2 by y1. Okay? So to find the ratio, you just divide y2 by y1. We'll do an example of that. The graph resembles an exponential curve. So it's going to look like this, where it's flat on one side and then increasing fast, or it's going to look like this, where it's decreasing fast and then flat out.
Just keep that. Want me to plug it in? Sure. Sorry, mine.
That's okay. The equation of the exponential is written like this. Y equals a with a b to the power of x. Do you guys remember this? A b to the power of x. Well, we had y equals a with 2 to the power of x. No? In the previous one, we had y equals a 0.5 to the power of, it doesn't have to be x, it could be t over h or t over d, right? But just a quick reminder of how the formula is going to look like. Or we also had a equals a naught 1 plus I to the power of x. Do you remember all of this? So these are all exponential functions, right? Where a is the initial value and b is your growth, decay, or growth or decay factor. And then the exponent is the variable. B to the power of x. Yep. When do I call it a growth and when do I call it a decay? When the base is greater than 1, then I call it growth, and when the base is between 0 and 1, it's called a decay, right? So if b is greater than 1, the relation is growing. And when it's between 0 and 1, the relation is decaying. Now, it's very important that you understand the difference between the terminology growth factor and growth rate. They're two different things, okay? The growth factor is found by adding 1 to your growth rate. So let's say if your growth rate was 5%, right? What would your growth factor be? 1 plus 0.05, right? So your growth factor is 1 plus 0.05. Okay? So there is a difference between growth factor and growth rate. You guys have to understand the difference, and you have to know how to.
Sarah, we're all coming in here.
Come on.
This is the
You
only
like
class
to
that
learn
worries
this?
on me,
And
yeah.
then- By the way, I know. I'm the only one working.
Wow. I went into your class, it would taste like a shower. Somebody has cologne on by the leader.
I can't do it. I'm out.
Maybe go boost the car.
And this is, we're recording, but this is part of the policies.
Oh.
No using perfume. Anyway, so if you want to find, if you know what your growth factor is, so 1.05, how can you find your growth rate?
-1.
That's right. So take your growth factor and take away 1 from it, and then you can find the growth rate. So these are the formulas that you basically need to know, but you don't need to memorize them because you're going to use common sense to find them, right? There you go. Do we understand it though? Do we understand the difference between the two? So the growth rate is your percentage. The growth factor is 1 plus your percentage, but in decimal. You have to change it to decimal. When we have a decaying formula, how can I find the growth factor? Or the decay factor? 1 minus the decay rate, right? So if let's say you have a car and it's depreciating by 5% every year, right? What is your growth, what's your decay rate? That's your decay factor, right? Your decay rate is 0.05. So in order to find the decay factor, you do 1 minus 0.05. Okay? And then if you want to find your decay rate, just do 1 minus your decay factor, which is going to be 0.95. Okay? So let me give you the example. So you have a decay rate of 5%, right? To find your decay factor, you do 1 minus 0.05, which is 0.95. So your decay factor is 0.95. Are we okay with this? Now, if I give you the decay factor, and I say, this is another example, and I say this is your equation, and I ask you to find the decay rate, what do you do? What would be your decay rate be?
1
minus 0.75.
Which is what?
That's the
I don't know.
Which is 0.25, which is 25%. Right? Right? So, depending on what the find the other one, okay? And make sure you read your question properly because it's only a matter of reading it wrong. And then you're gonna get the wrong answer.
Yeah.
Right? Okay, so we should be able to look at the question, and if we have a table of value, how can you find if it's exponential or not?
Y.
That's right. So y2 divided by y1, that's with the table of values. If it's a graph, what am I looking for? How would it look like? Flat on one side, and then either growing or decaying at the other side. And then if it's an equation, I'm looking for a variable in the exponent. Okay? So in this case, it's a table of values. So if I want to know if it's an exponential relation, I have to do the ratio. So I have to do y2 divided by y1.
Right this time.
You divide. Yeah, that's why it's called a ratio, right? The other one is called difference. So subtract.
Okay.
So you take the y2, you divide by y1. So 15 divided by 25 points. And then 5 divided by 15 is 0.33. Yes?
Isn't it 35 divided by 25?
No, it's y2 divided by 1. Remember, it's the same thing as when we were doing the difference, right? With the difference, we start at the bottom minus the top, right? Bottom minus the top. Same with the ratio. You do bottom divided by the top, you will find your ratio. Remember that if this was, is this constant ratio? No. So is it exponential? No. Right? Because if it is exponential, then you must have a constant ratio. Remember the question when we were doubling, right? The ratio was 2 every single time, and that was my base.
Right.
Okay? So, in this case, we're going to say that it is not exponential. Because the first, or the ratio, is not constant. Okay, we're going to have to do the same thing for the second table of values. So you're going to take the y values, which is in this case their p, and then you're going to divide 64 by 51.2. And that is 1.25. $80 divided by 64. And that is 1.25, rounding to 2 decimal place here. And then 100 divided by 80 is 1.25. What can you tell me about this ratio? It's constant. What's up? Eric?
How can we divide the bottom or the top of the first time, and now it's the top of the divided by bottom?
I'm always dividing the bottom, so 64 by the top. Right? So 25 divided by 35.
Yeah, Eric.
I don't know why I'm thinking it's being weird.
What's going on?
Bill. Yeah, what's that?
don't text.
Not as much, I guess.
Okay, so because the first ratio is constant, right? You see that the first ratio is constant, then it's an exponential. Are we okay with this so far?
Yeah, no.
What part?
We don't need to stop the class, I'll look at it after. but-
Okay, so come and see me
I-
after.
yeah.
Alright, so you see this ratio that we got here, the 1.25? That is actually your base of your equation. So if you look at the y equals ab to the power of x, right? That 1.25 will replace the b in your equation. Okay, so what would be your initial p-value? Say 1.2 because that's the one at 0, right? So your initial is gonna be 51. So I can actually write an equation for this using the table of value. I know A is 51.2 because that's where my D is 0. The base is 1.25 because that's my ratio. And then your exponent is gonna be the variable x. This is a little extra to the question. The question is not asking you to do this. I'm just showing you this as an extra thing. That's why it's on this. Okay? So, table of value, to know if it's exponential, you do ratio. Let's see what else do we have. So, in my second examples, I have graphs. Can you identify the exponential graph? Which one? D. D is your exponential graph, and how do you know that? It's not a straight line, right? It looks like it's gonna be, it looks like it's increasing fast, right? It has a fast increase, right, as x is increasing. And then if I continue this graph, it should look like this on the negative x values, okay? So this is an exponential graph. How about this? What do we call this?
Yeah.
A linear graph. So not exponential for the first one. Second one, exponential. Flat on one side. And now, looking at the equations, which equation would you say it's exponential and which is not? E is exponential, and how do you know that? That's right. So your exponent is a variable, right? What would this be? Quadratic degree 2, right? Good.